In this section, we're going to talk about Venn diagrams some more, and we're going to talk about the operations that are used whenever we're discussing Venn diagrams. They kind of work with their own set of rules, so we got to talk about those. So if you'll recall from before, we already talked about what the complement of a set was. They called it set F, and we called it F with a bar on top, and that meant not. That meant all of the things, the x's, that are in the universal set, but they're not inside of set F. So this was similar to like a negative in math. So when we say not F, that complement idea is similar to the idea of a negative. But that only works on one set at a time. So set F. We have F and then we have not F. So what if you want to work with two sets at a time? Well, it kind of depends. How do those sets look? Do they overlap or do they not overlap? So this would be like your universal set is the rectangle, and then inside we have sets A and B, and you can notice that they don't have any elements in common. So all of the elements that are over here in set A and all of the elements over here in set B, there is no overlap. So that's what we call disjoint sets. Normally what we see are sets that actually overlap. So A has elements, B has elements, but they also have some elements that are similar to both sets. So like those values would be inside set A, these values would be inside set B, and you can see that there's an overlap. So most of the time we work with overlapping sets. So the type of operations that we don't have adding, subtracting, multiplying, dividing. That's not a thing. What we have with Venn diagrams is the complement, which we already talked about, and then we have the intersection and the union. So these are the big ones for this particular part. The intersection. The intersection is what you think it is. It's where the two circles intersect, or like if you have two streets, they intersect, like it's called an intersection when two roads intersect. So where these two sets intersect, these two circles, it's this little football shape. And what's unique to that little football shape is it's all the elements, or all the things that are elements of set A, and at the same time they are elements of set B. So they happen to be sitting in set A and set B at the same time. That's what that intersection is showing us. And so it's this little football shape in the middle. That's kind of the shape you want to look for when you see an intersection. The symbol they use for intersection is this little, it's like an upside down U. It kind of looks like a lowercase n if you're really creative. So you can think of it as intersection, but really it's a little upside down U. There's no straight lines on it. So that's the symbol that we use for and. So it's got to be in both sets to be in the intersection. The union is much less restrictive. The union is as long as you show up either in set A or set B, whichever one, just show up in one of them, you're in the union. So it uses the word or. It's the elements that are in either set A or elements that are in set B. So this one you want to look at both circles together. It's a union, like people call marriage a union, if like two families coming together as one. So this union of these two sets, it would be everything as long as it shows up in either A or B, then it shows up in the union. So these are kind of the shapes you want to look at. For union, they use the symbol of, it's like a little U. And so U is union, and the one that looks like an N is intersection, if you want to think of it that way. So let's actually put this into practice by looking at some sets and arranging the numbers on the Venn diagrams and then looking at the intersection and the unions. So it says for each of the following, find A intersect B and A union B. Express each as a set. So that means we're going to need curly brackets and all that good stuff. So let's see, first of all, set A has the numbers 1, 2, and 3. Set B has 2, 3, and 4. The first thing you want to do is look to see if you have any numbers that are repeated. So like both sets have a 2 and both sets have a 3. So that means they show up in both. You should put them inside the intersection. So arrange the intersection first. That's always where you want to start. Now, what does A have besides the 2 and the 3? Well, it has a 1, and the 1 is not in set B, so we just need to put it over here on the left side of set A. So A now has 1, 2, and 3. Set B has 2 and 3, but also 4. So that's how the numbers would be arranged in the diagram. And if we want to look at the intersection, I'm going to do the intersection first here in yellow. The intersection is always this football shape in the middle. So what's included in the intersection? 2 and 3. And they are their own little set. So separate with commas and put curly brackets. So 2 and 3, that's the intersection. The union is going to be both circles together, like anything that shows up where I just outlined in purple. Any of the numbers that show up there, that's going to be the union. So that's going to be all of them. 1, 2, 3, and 4. They all show up in the union, but the intersection is just the middle part. So maybe by color coding that'll kind of help a little bit as we go through these. Let's try another one here. Okay, so we have set A is 1, 2, and 3. Set B is 1, 2, 3, and 4. So again, I'm going to start with the ones that they have in common. They have a 1 and a 2 and a 3 in common. So 1, 2, and 3 are all going to go in the center. A does not have any more elements, so there's nothing for me to write out here. There's no more elements inside of A, that's it. But B also contains 4. So that's the way that those numbers would look if we arrange those. And again, to find the intersection, that's the ones that overlap. That would be the little football shape. So that is going to be the numbers 1, 2, and 3. My little curly brackets. And then for the union is like a big hug. It's going to take everybody into this big hug. So that's going to be all of them, 1, 2, 3, and 4. As long as you show up, you're in the union. Just got to show up in one of the letters, A or B. So for the last one, set A contains 1, 2, and 3. Set B contains 6, 7, and 8. So the first thing I notice when I look at these is there is nothing in the intersection. There is no overlap. So I'm going to leave the intersection empty. But I do know that 1, 2, and 3 are inside of A, and 6, 7, and 8 are inside of B. It's just they don't have anything in the intersection. Like they're kind of separate. So actually the two sets, those two circles could have been drawn as separate circles. So when I'm looking for my intersection, you notice it's empty. So I think what you should say for the intersection is just empty brackets, right? It's empty. So you're showing it's a set with nothing inside, or you could say it like this. I kind of prefer this empty brackets, whichever. Just make sure this is truly empty. Empty. All right, what about the union? Well, the union is kind of like a big old hug, so it's going to grab everybody that shows up, put them in a hug. So it's just going to be 1, 2, 3, 6, 7, and 8. So there's an example where the intersection is actually empty and the union is everybody else.